I'm going to do a couple of examples of inverse trigonometry, and we're going to start off by drawing a right triangle, and I'm going to go ahead and give you two side dimensions, and what we're going to do is we're going to use inverse trig functions to figure out the angles. And so we'll go through a couple of problems just so you can get the hang of it. I'm going to say that this side over here is 5 3/4 inches, and over here is going to be 42 7/8. And you know, let's look at our triangle with our dimensions given. Notice, of course, this is going to be the 90-degree, and we're going to use inverse trig to figure out these angles, and I'm going to call this one over here angle A, and this one up here angle B. Okay, now what we want to do is we want to label our sides in reference to one of the angles, and so we just have to arbitrarily choose one angle, and it really doesn't matter which one. So I'm going to say let's solve for angle A. Okay, and I'll just put a little underline there. Now I'm going to go ahead and reference my sides in accordance to this angle here, because you know it will be different, or at least this side will be labeled different if I'm referencing angle B. So according to angle A, this 5 3/4 will be the opposite side, and the 42 7/8 will be the hypotenuse. Now I'm going to go ahead and write my functions, so, ca, and toa, and again that represents sine, cosine, and tangent. And we're going to use these functions similar to how we used them just doing regular old trigonometry when we were solving for a side. Instead of looking for a function that has a side that we have and a side that we want, we're going to choose a function that has both the sides that we have. So for instance, in this one here, we have the opposite, we have the hypotenuse. So we're going to pick sine because that has opposite and hypotenuse in it. Now the way we write it out is going to be a little different than when we were just doing strict trigonometry. We're going to use a little looks like an exponent, like a -1. But let me go ahead and write this out, and then we can go over it. So it's going to be sin, because that's the function, and in the upper right we're going to write a -1. Okay, and that's going to indicate that we're taking the inverse of sine, and so what we're going to do then is to plug in the ratio, the numbers into the ratio. So opposite's going to go on top. That'd be the 5 3/4, or 5.75, and then the hypotenuse, which is the 42 7/8. So I'm going to 42 875. Okay, and then we would just hit equals. So sin with that -1, that -1 is telling you that we're using the inverse sine function, and whenever we're doing inverse, that means we're looking for an angle. And then we just plug in the numbers into the formula. So I'm going to go ahead and show you how to access that inverse function. Okay, we're going to go ahead and press the second key, and the reason that is if you look at, here's the sin button, and if you look above, let me see if I can zoom in here. If you look above the sin button, there's a sin with a -1. We're going to access that by hitting the second key button first, and then we push the sin button. That will bring it up. Notice that above the cosine button there's a cosine with a -1, and then the tan, or the tangent, there's tan -1. Those three functions are for finding angles, and that is for inverse trigonometry, what we're doing right now. So I'm going to go ahead and hit second sine. And notice you can see that -1 and an open parentheses. We're going to now input this ratio. So it's going to be 5.75 divided by 42.875. So I'll go ahead and input that. Now you can use a closing parentheses, but you're still going to get the answer. It looks like it's a small angle, and we can go back and make sure we punched everything correctly. It looks like we did. It's a small angle, and let's go ahead and round to 3 decimal places. When we're calculating, we're generally going to do that, and then at the very end we'll go ahead and round to the nearest 10th degree. So I'm going to zoom back out because we don't need to be this close anymore. Okay, so angle A is 7.707 degrees. Notice that's not in inches. We do not need to convert this to the nearest 16th. We're only going to do that when we're working with, when we're trying to figure out the side dimension. Now there's a couple of ways you can go about figuring out angle B. And so I'm going to show you a trick. And so I'm going to leave this in the calculator. Now, if you were to take the angles, all the interior angles of this triangle, and add them up, so we know that's 90, that's 7.707, and that we're going to figure out. But basically, you can rely on the information that the interior angles are going to add up to 180 degrees. Okay, now because this is 90, we know that's a 90, we could take 90 away from 180, and that gives us 90 degrees left. So these two, A and B, have to equal 90 degrees. Okay, now knowing that information, if we, I'm sorry about the shadow, but if we take this away from 90, we will get angle B up there. Okay, now here's the trick. We're going to leave this in the calculator, and then we're just going to punch in 90 minus second, and then down here where it says ANS, that means answer. So the second answer, or the answer that was previously on the screen, the calculator is now bringing that up, and then we're going to hit enter. So we've essentially, what we've done here is we've taken this amount and we've subtracted it from 90. And we did that by not even having to punch this number in because the calculator brought it back up. So our angle B is now going to be 82.293 degrees if we're rounding to the 3rd decimal place. And to double check, we could just add these two together, and you could do that by, you know, going 7.707 plus 82.293, and sure enough, it is 90. So if you weren't believing me with that little trick, you know, I just proved it here that that's going to work out. Okay, so that's one way you could figure out angle B, and that is certainly the easiest way. And I recommend doing it that way. But say, for instance, you decided, well, I'm going to solve for angle B first using inverse trig, and then use that little trick to find A. So let's go ahead and do that. Let's go ahead and label our sides in accordance to angle B, and I'll circle B, and I'll use pink. And so now this side here is not going to be opposite. Instead, it's going to be adjacent. And this side, of course, will still be the hypotenuse. So again, I want to pick a function that has both adjacent and hypotenuse. And if you look over here, it looks like cosine will have adjacent and hypotenuse. Okay. So we're going to go ahead and rewrite it. So we get cosine, and that little -1 in the upper right hand corner, that's going to tell you that it's an inverse function and we're looking for an angle. So that means we're going to write it as adjacent on top, which is 5.75, over hypotenuse, which is 42.875. 7.5. And notice it looks very similar to this setup here, but notice the function is different. Okay, and we should come up with this answer here. So let's go ahead and plug this into our calculator. We're going to go second cosine 5.75 divided by 42.875, and we get 82.2927, so I'm going to round that to 3. Notice that it is in fact the same as when we did our little trick. And so if I were to do my trick to find angle A, just again, real quick practice, don't clear it, just go 90 minus second answer equals. And you get 7.707, which is what we have here. Now, let's go ahead and round these two angles to the nearest tenth. This angle B, or here we'll start with angle A. So angle A is going to be 7.7 degrees. Remember, we're not converting to 16th. Angle B is going to be 82.3 degrees. And again, if you were to add those, we're going to not get 90, or yes, excuse me, we are going to get 90. 7 plus 3 is going to be 10, and that's going to bump that 7 up. Anyway, that is basically how you're going to find the angles. And if you're continuing to have difficulties, let me know, and we will certainly go through more examples in class.